All right, today we're looking at another sequence. This one happens to be a geometric sequence. Notice it does not say arithmetic. You'll have two types of sequences that you need to know for this chapter. And a geometric sequence has a common ratio. So what does that mean? It means fancy talk for multiply. So down here I have three sequences. Let's take a look at them, boys and girls. I have to first decide what kind of sequence I'm looking at. Arithmetic or geometric? What did I do to 2 to get to 4? I added 2 on. What did I do to 4 to get to 6? I added 2 on. What did I do to 6 to get to 8? I added 2. What did I do to 8 to get to 10? I added 2. So we have just figured out that this is an arithmetic, because arithmetic means to add. And we found out that the common difference is 2. Okay, so we go down to our next one. What did I do to 2 to get to 4? I added 2 on. What did I do to 4 to get to 8? I added 2. Wait, I didn't add 2 on. So this is not arithmetic, because I'm not adding on the same amount each time. Let's look at something else. What's another way 2 can get to 4? Well, I can multiply by 2. Does that work for every term after? Yep. If I take each term and multiply it by 2, I get the next term. So this is an example of geometric, because geometric means to multiply. And instead of the letter D, we use the letter R, and that means it is 2. Now, ratio is a fancy word for fraction. And that means I'm multiplying by some fraction. Now, in tonight's homework, they may give you a little trickier ones. For example, what did I do to 3 to get to 4? I added 1 on. That's always going to be your first guess. But as soon as you look here, 4 plus 1 does not get you 16. So out goes the arithmetic. Your next choice is to always try the geometric. What did I multiply 3 by to get to 4? It's not so obvious. What did I multiply 4 by to get to 16 over 3? So I'm just going to set up a little Algebra 1 problem and see if this is geometric. Let's test it. So here's my test. 3 got multiplied by some ratio, and that got me 4. If I solve this, my ratio is 4/3. So what I think is that everybody got multiplied by 4/3 to get the next number. So I can check this out. I'll take the number 4, I'll multiply it by 4/3. Did that get me 16/3? Yep. Okay, so then I'll take 16/3. I'll multiply that by 4/3. And does that get me 64/9? Yes. So for this example, you would say, okay, it is indeed geometric. And it had a little uglier common ratio of 4/3. You have two more formulas that you have to know. The recursive formula and the explicit formula, and they are just like addition. The recursive formula says to find any term, we take the term before it and multiply it by the common ratio. Now, the recursive, we know, doesn't always work, especially if they want us to find the 1000th term, because who wants to make a sequence go out in 999 spots? So the explicit says to find any term we start with the first term and we multiply it by n minus 1 power ratios. All right, so let's put these formulas into action. First thing in the homework tonight, they're going to ask you the simple questions. They're going to give you a bunch of sequences, and you have to figure out, is it arithmetic, geometric, or it's neither. Okay. What did I do to 4 to get to 12? I'll check arithmetic. I added 8. Does 12 plus 8 get me 36? Nope. So therefore, this is not arithmetic. Let's try geometric. What did I do to 4 to get to 12? I multiplied by 3. Does that work for everybody? 12 times 3 is indeed 36. 36 times 3 is indeed 108. And 108 times 3 is indeed 324. There's my answer. This was geometric. And if they happen to ask you, the common ratio is 3. That's what I multiplied everybody by to get their next term. Let's put this recursive and explicit to the test. After they have you figure out whether it's geometric or arithmetic, or neither, they're going to ask you to find terms. So this one says we want to find the 10th term of this sequence. 4 is the first term, 12 is the second, 36 is the third, 108 is the fourth, 324 is the fifth. So we can see it's the geometric sequence that we just had in the previous example. So we could take this the long way, and we could find the 6th, the 7th, the 8th, the 9th, and the 10th by doing the recursive formula. To find the 10th term, because that's what n equals, we would have to take the 9th term, the term before it, and multiply by the common ratio. But the problem is, when we look at the 9th term, we don't know what the 9th term is. We'd have to backtrack to get there. So we're going to work with the explicit formula. The explicit formula can get us right there. It's like the express formula. To find the 10th term, I'm going to start with the first term, which we know is 4, and multiply it by 3, because 3 is the common ratio. N minus 1, well, if n were 10, 10 minus 1 is 9. Now, why is it 9? Because look, here's 4. How many common ratios are in between my first term of 4 and my last 10th term? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to take 4 and multiply it by 1, 2, 3, 4, 5, 6, 7, 8, 9 threes. And it's much easier to rewrite this as 3 to the 9th. So now the rest is just little old calculator work. 4 times 3 to the 9th, and I get a big old term. The 10th term is 78,732. And then the last thing they have you do is figure out geometric terms in between two given numbers, just like we did with arithmetic. So here we have the numbers 4 and 100. And they want us to find three numbers in between 4 and 100. And they tell us that this is a geometric. That in other words, 4 was multiplied by something to get the second, and then that was multiplied, and then that was multiplied, and then that was multiplied. Okay, common sense says this. I took the number 4 and I multiplied it by some ratio. And how many ratios? 1, 2, 3, 4. I multiplied them by 4, and I raised it to the 4th power. And that got me to 100. Once again, this is the explicit formula. Any term is found by taking the first term and multiplying it by r raised to the n minus 1. Well, I have 5 terms here. Don't know what the common ratio is. And then this would be 4, because 5 minus 1 is 4. And I do know what the 5th term is. It's 100. I do know what the first term is. It's 4, r to the 4th. So see, it's the same formula. Now I just have to solve it. Alright, so I'm going to divide by 4, divide by 4. R to the 4th power gets me 25. How do I undo a 4th power? I 4th root it. And do not reach for your calculator on this. Because if you reach for your calculator, here, let me do it for you. And I want to take the 4th root of 25. I get an ugly answer. I don't want ugly decimals. I want exact. So, r ends up being the 4th root of 25. Now, the 4th root of 25, if you remember from the beginning of the year, I told you to take a 4th root quickly by doing 2 square roots. So I want to take 25 and I want to square root it twice. Okay, square root of 25 is 5, and I still have a radical, so my ratio is the square root of 5. Now my problem's not done there because I said find the 3 numbers between 4 and 100. Alright, so that means this 4 has to get multiplied by radical 5. That gets me 4 radical 5. Now that 4 radical 5 has to get multiplied by radical 5. Radical 5 times radical 5 is 5, times 4 is 20. And that has to get multiplied by radical 5. So this is 20 radical 5. And then 20 radical 5 multiplied by radical 5. 5 times radical 5 times radical 5 is 5. And 5 times 20 is 100. There. Those are my answers. Those are the 3 geometric means between 4 and 100. Bye.